So the title of my talk today is How to Slay a Dragon. And I'm Adrienne Porterfeld. I have been on the Chrome security team for about 6 years. I focus specifically on usable security. And I've also actually been working on some feature work as well lately, which is kind of fun because I get to see security from both sides. I get to see it from being a member of the security team, but also from the side of being a product team member where some of my features go through security reviews. So it's kind of fun to experience product security from both angles. Now, the main thing that I have learned from 6 years working on product security is that security is very full of very hard problems. I am sure that many of you already know this yourselves, but let me give an example. Site isolation. Some of you may already be familiar with Chrome Site Isolation Project. I don't personally work on it, but I've had the pleasure of seeing my colleagues work on this. Site isolation is like a modern engineering marvel. So my colleagues, Nasco and Charlie and their team, had this vision that they were going to re-architect all of Chrome's navigation and process code. And the dream was to make Chrome a truly one origin per process browser. Now, the benefit of this is that if you have every website in its own process, then you can rely on strong operating system primitives to protect websites from each other. Now, the challenge here is that when you try to do this, you have more processes, you break a whole bunch of assumptions that are built into the browser. So the site isolation project wasn't hard just because the engineers had to refactor a bunch of code. It was hard because they were faced with trade-offs. Do we want more security, or do we want the browser to use less memory? And after Spectre happened, after people became aware of this class of attack, site isolation suddenly became a lot more important because there were more risks. And that pushed the balance pretty clearly in favor of security, even though it came at the cost of some additional memory overhead. But so this project was hard for the same reason why a lot of other security work is hard, because security is the art of managing trade-offs. Maybe there are some cases where it's a clear where there's a clear path forward to solve a security problem without incurring any trade-offs. But at least in my experience, often security really is a trade-off between security and something else, and you have to try to figure out how to make them both work at the same time. So for site isolation, that trade-off is between having stronger isolation between websites, but at the cost of additional memory overhead. For another example, as an enterprise, do you want to require your employees to rotate their passwords often? If you do require them to rotate their passwords often, they will probably forget them. They're much more likely to get locked out of their accounts. So this will incur some real human cost. But on the other hand, it probably will also reduce how often password reuse happens. So here, you're facing a trade-off. Now, my call is that you're better off allowing employees to have very strong passwords that they remember and use for a very long time. But there are two sides to this, right? There's trade-offs on both sides. And there's often this type of situation where there is no right choice when it comes to security decision making. I call this type of situation an impossible problem because it only has imperfect solutions where we have to weigh hard to quantify risks with maybe easier to quantify costs. And in this type of situation, your solution or your decision is probably going to make people unhappy no matter which direction you go. And over the last few years, I've had the fun opportunity to see my colleagues tackle several problems like this that were very hard problems that were very worth solving, but that solving them was always going to come at a cost no matter which direction they went in. And I've had some opportunities to tackle them myself. So today I am going to be talking about my 3-step strategy for how to slay a dragon. And here by dragon, I mean an impossible problem that doesn't necessarily have any clear winning solution. So, okay, so once you realize that you've got this problem, you've looked it in the eye, you've sized it up, you realize the problem is bigger than you, the first step is to turn around and fight its little cousin instead. Hopefully the cousin is more your size than the big dragon. And by this, I mean the first step to solving an impossible problem is to figure out what the easy solvable variant of that problem is. And I'll give some examples of what that means. And you can do this over and over again, chipping away at little pieces of the problem that feel tractable or feel easier than the rest of the problem. The second is accepting imperfection and criticism. By this I mean, if you're in a situation where there's a really hard problem with no good solution, but you think it's important to solve it anyway, you're going to have to accept the fact going into it that after you've solved all the little problems, fought all the little cousins, you're going to be in a situation where you're still going to have to eventually make a hard call in the name of security, often since we're the security team, that is not going to be perfect, and you have to be comfortable with that and okay with it. And I'm stressing this point because I've seen a lot of burnout in security folks, as they aren't able to, they just aren't able to come to the step of, okay, this is a hard decision and we have to make it and move on. But then third, that doesn't mean you forget, right? You understand that there's a cost to this decision, and then over time you pay off your debt, and you try to reduce the amount of cost that the decision may have made. Now, this all sounds maybe very abstract, so I'm going to walk through 3 case studies, or 3 examples. Two that I think went well, and one that's still in progress. So only time will tell if it actually went well or not. The first that I'm going to talk about in some more detail is site isolation. I haven't worked on this myself again. I can't take credit for this work, but I have been able to watch my colleagues tackle this. It's a shame that we don't have slides, because there's this amazing dependency graph that Charlie made that is actually so big that I wasn't able to put it all on a screen. But basically, when they were thinking about what they would have to do to make a truly one site per process browser, they made this crazy huge dependency graph showing all of the blockers and all of the things that would break and all of the things that would be slow. And it's this crazy thing that doesn't fit on one screen. I honestly don't even know how they looked at it. But the truth of the matter is that attempting a project like that is enormous in scope. It's going to take many years and many people, a lot of patience, and also a lot of executive support to ask for forgiveness when things do eventually come at a cost. And so the small version of this problem that they tackled first was to, instead of thinking right off the bat, how do we isolate everything from each other, they started with web iframes in extension pages. Now, Chrome has an extension system, and in the extension system, you're able to, extensions can have their own pages that are more privileged than a typical website. Examples of extension privileges are things like the ability to read and write your content on all pages, access to web permissions that maybe the website itself doesn't have access to, and so forth. So they're significantly more privileged than a typical website, which makes them a pretty appealing attack surface. So extension pages have, maybe this outer frame that's highly privileged, and then they'll commonly embed web content inside of it that is supposed to be much less privileged. Now, the idea here was to start with this problem. Can we isolate the web frame from the outer extension process by putting the web frame in its own process? And this is an appealing subproblem because the risks are obvious. The extension page is very highly privileged, and also the costs are lower. People don't have that many extension pages open. This just doesn't come up as often. It's not the same as the full problem of trying to isolate all origins from each other. So this is where they started. And once they did that, they sort of slowly expanded out from there, looking for more and more cases where they were able to isolate content, until one day the Spectre attacks happened. And by good fortune, they'd already been working on this project for many years, and they were able to do a full launch to help mitigate the Spectre attacks. But with that being said, step 2 of how to slay a dragon is accept imperfection and criticism. after site isolation launched, I think there was a lot of positive excitement in the security community, but there also were some press articles calling out Chrome. I think I have one here entitled, "Why Google Chrome Now Uses More Memory." Entirely framing it from the perspective of, oh, we hate this new feature because it causes Chrome to use up more memory. Chrome's such a memory hog. So, this amazing engineering feat of separating all websites from each other, is still not going to make everyone happy, and that's okay. I still think it was very much so the right decision to launch this. And over time, the team is now in the third phase of paying off debt. So they're still working hard to bring down the costs and reduce any breakage that came from the launch of this feature. The next thing I want to talk about are security indicators. So this is a project I worked on for a long time. I don't know if any of you can remember 2015. Feels like it was a long time ago at this point. But Chrome security indicators at that point looked pretty different. And from user research trips, from bringing people into the lab, from running surveys, we realized we had a problem, which is that we were putting a connection security indicator next to every URL on every page right at the top. And in fact, on mobile, taking up quite a lot of the screen in order to do so. But people didn't really seem to be understanding what they were there for or what they meant. And this is unfortunate because we really wanted those indicators to work. What we really wanted people to understand connection security state. We wanted people to know when the information that they were submitting was going to be on an HTTP website versus when they were using an HTTPS website that would keep their content protected in transit. Now, an unfortunate truth here is that this is a really technical concept, trying to understand connection security. You have to have some model in your head of how data moves between your device and the server, or even what a server is. So sort of starting off, this is a hard problem to explain to users. But and according to our research, our indicators weren't doing a great job. People didn't think the HTTP indicator looked bad. I don't know if you remember what it looked like, but at the time it was a little thing that looked like a page with that was dog-eared on the corner, folded over. And yeah, okay, so people didn't think that looked bad. So they would say, oh, HTTP is, it's a normal page, or maybe I bookmarked it, or they weren't really sure what the indicator was supposed to indicate. And that was fair, right? That indicator was a very neutral, this is a normal page type indicator. And we wanted to make it more clear to people that HTTP was actually a little bit dangerous because your content wasn't being protected in transit. Now, imagine what would have happened if on day one we had tried to put the words, make some red non-secure indicator and slapped it on what was at the time about 80% of page loads. People would have freaked out. I bet they would have noticed it then, but people would have said, oh my gosh, using the internet is not secure in Chrome. Chrome has a problem. I'll go use these other browsers that don't show me this horrible, scary thing. Or maybe even worse, they would have just stopped using the web altogether because it would have really freaked them out. Now, another problem, on the other hand, is that people also didn't know what the HTTPS indicator meant either. We've been telling people for years, oh, look for the green lock, look for the green lock. Okay, maybe there's a lock in the page, right? Where is this green lock supposed to be? Why does it matter if it's there versus there? A lot of people are confused about that. And as the scale and scope of the internet has been growing, a lot of people who are coming online have never heard that advice at all. So they don't look for a green lock anywhere. They have no idea what a green lock is or what it's supposed to be. When talking to some people about what they thought about the connection security indicators, theories included it's green because Americans think green is lucky, oh, this is a shopping website. That's the checkout cart, which is a really good point because shopping bags, in the shopping bag indicators, are often the same shape. Sometimes they're also green. And even technical people got confused. A lot of people have equated HTTPS with this page is safe. right? It doesn't mean this page is safe. It means the connection between your device and the server is protected, is encrypted, authenticated, but a lot of people would take it to mean some entity has verified that the content of this page can't hurt you. And that's not what it means. So even technical people would be confused by this. And also we had some problems with accessibility. Basically, the three shapes at the time were a green lock, a gray lock with a little yellow triangle on it, a gray lock with a little red X on it, and the page indicator. And these shapes all kind of look like each other. And that wasn't really great for accessibility. So this seemed like an impossible problem at the time when we first started out. We weren't really sure how we were going to make any progress on getting anyone to understand any of this. OK, so step one, fight its little cousin instead. We thought about what the easiest versions of this problem were. So the first change we made was just a simplification. We turned this confusing array of shapes into just three shapes that were all very distinct from each other: a green lock, a gray circle, and a red triangle. So at least we've solved the accessibility problem. All the shapes are now distinct from each other, and it's a little simpler to see the difference between the three. We also decided that at this point that it would actually be easier to ask the entire internet to move to HTTPS than to get end users to understand the difference between HTTP and HTTPS. So we partnered with other browsers like Firefox and with organizations that are great, like Let's Encrypt, to ask developers, like, hey, please just make your site secure by default, right? We don't think users are going to understand whatever we do to these shapes, so please move to HTTPS. And this actually was, I think, an easier problem than trying to, like, I don't know, I could visit 3 billion people and give them a little lecture on HTTPS versus HTTP. Reaching the set of web developers, particularly the smaller set of popular sites, and explaining this problem to them actually worked a lot better. So today we now see, something like 80% of page loads are now over HTTPS, and something like 90% of browsing time is now over HTTPS, which makes this problem a lot easier, right? Most of the time, you don't need to know about the connection security state of the page because it's secure by default. But step two is accepting imperfection and often valid criticism. One of the hard parts of this process was that we wanted to associate words with the indicators so that people could learn what the indicators mean. Because just showing someone a green lock and not telling them what the green lock is supposed to mean doesn't really accomplish anything. You have to tell them somehow what it means. And without access to Santa Claus's time-dilating sled that allows him to visit everyone in one night, the only way you can do this is through a little bit of UI. And you can't do this through like an essay. It has to be 1 to 3 words. OK, choose 1 to 3 words that have to be short in all 40 languages that you translate into, what the green lock means. And we tested a bunch of variants, and the best thing we could come up with was the word secure. Now this is kind of problematic. I alluded to this earlier. When a lot of people see the word secure at the top of a website, what they think it means is that the page content itself is secure. And we did see, I think likely as a consequence of this, that many more phishing sites started adopting HTTPS. And I think I'll make the assumption that the reason they were doing this was because they were finding it was effective. And I'll admit that weighs on my conscience a little bit, that part of this trade-off that we made here of trying to explain what connection security means also made it easier in some cases to target people for phishing attacks. But that was the best we could do to explain it, and we needed to explain it, because without explaining that there's a difference between these two states of secure and not secure, what are you going to do? So The third step is paying off your debt over time. And I am very happy that if you use Chrome today, what you'll see, at least on the beta channel, and I forget if this is launched to stable or about to launch to stable, but it no longer says secure next to secure pages. It just says not secure next to not secure pages. Because over time, as we flipped that default, it meant that we were able to now identify the not secure pages instead of the secure pages, and so it took away the need for us to label the secure pages. So I'm very happy where we ended up. Most of the web is HTTPS. I think people don't need to understand the difference, and if they do, we're negatively labeling the insecure case. But there were some hiccups along the way. I still think it was a problem worth solving, and I'm glad we tackled it. But it's never going to be a perfect process when you try to tackle a problem like that, especially in a field like security that involves people, where a lot of the work is qualitative and subjective. The third story I want to talk about is a story that's still in progress. It's the topic of displaying URLs. Some of you may know me from my greatest hits, such as Google wants to kill the URL. Thank you, Wired. That is not what we're trying to do. What we're trying to do is figure out how to help people understand website identity. Now, when the people in this room want to check if a page is phishing or not, I assume what you do is check the URL bar. And then when you check the URL bar, you're able to understand, OK, this part is the path, this part is the domain, this is the subdomain. And you can figure out most of the time whether or not this is a phishing attack by going through that process. This doesn't work quite as well for end users. The good news is that actually doesn't matter most of the time. Most of the time, people are on good pages, like the New York Times, which has the words "The New York Times" emblazoned all over it. Like, you're not going to be wondering on the New York Times website, am I on the New York Times website or not? Because they really want you to know that you're on the New York Times website. So when you're on those types of pages, it doesn't matter that the URL bar isn't helping you. But when you're on the bad pages, the ones that look exactly like a Google login, but have tinyurl.com or Bitly or something else on the top, that's where the URL bar is supposed to be doing its job. That's where it's supposed to be telling you something about website identity. And for this reason, for years when doing security reviews, I would tell teams, you have to put a URL display. You have to put a URL display. You have to put a URL display. I'm like, no, we want progressive web apps to take up the full screen. And screen as real estate is so limited. Why are you making me put this URL on the top? And I say, well, it's how we communicate identity. But in the back of my mind, I think I knew, and probably a lot of you may have suspected, that realistically speaking, that URL display on the top isn't actually telling people what we hope it's telling them. We ran an experimental survey in which we randomly assigned participants to a set of variations in how the URL looks. The experiment had a image of a Google sign-in page, and then we varied what was in the URL bar. It ranged from just the words tinyurl.com, like very emphasized, to sort of just a long tiny URL with lots and lots of stuff. Anyway, no matter what we did, no matter what conditions we tried to try to emphasize the URL, about 70% of people, between 60 and 70% of people say that they think it's fine and that they would enter their credentials into the site. And this is, by the way, in a prompted study where we're telling people that there might be phishing. So,
But you told them there might be phishing beforehand?
Yes. People were struggling with this. And that's really unfortunate. And another thing that makes this challenging is that even legitimate URLs are kind of confusing. For example, this is, okay, which one do you think is the real host of the Google blog? Is it www.google.blog, or is it www.blog.google? Everyone who thinks it's www.google.blog, raise your hand. One. Okay, does everyone think it's www.blog.google? Huh, okay, you're all right. I'm actually really surprised by that because when I give the talk, if I don't look at my speaker notes, I forget, get the wrong one sometimes. And like one of the challenges with URLs is that they're very confusing a lot of the time. I mean, AMP URLs are huge. They're very confusing, right? Because content is being hosted on the AMP cache. With new TLDs coming out, it's things can be confusing, and URLs can be long. You get into situations where I was trying to buy something on the FedEx website, which normally says fedex.com, and then it randomly sends me to some old Yahoo Pages checkout form, which I thought was phishing, but I confirmed is actually like something that FedEx has you put your credit card number into. This is such a squishy, hard problem to try to tackle. In part because power users really like how URLs are today. Everyone in this room is probably really skilled at using URLs. You understand how to change parts of the URL to get to a different website. You get a lot of information from reading the URL. And so if you try to change that, like there's the trade-off, right? So let's say we're trying to make identity clearer to one group of people. There's going to be a trade-off where maybe you make it harder for other people who really like URLs as they are now. And I think this is why no one has wanted to touch this problem, really, which is why URL bars look pretty much the same as they did in Netscape Navigator in 1994. I love that image, and I'm sad I can't show it to you today. If any of you have some free time, please go home and Google Netscape Navigator 1994, and you'll be shocked to see that URLs are displayed almost exactly the same way. So this is a new problem. This is a new area. I'm mostly trying to convince you all today that this is a problem worth solving. But we are starting at that first step of figuring out what the smaller, more tractable subproblems are. So one example is the fact that it's actually just really, really, really hard to write code that correctly handles and displays URLs. Like, forget the fact that users don't even understand what they're looking at to begin with, but the browser doesn't always do a good job formatting and displaying URLs as they're supposed to be displayed. This is counterintuitive to a lot of people. You're just displaying the URL, right? Like, just put it up there. It turns out this is more complex, particularly when you have to deal with small window sizes, like which part of the URL do you display or not? What happens when it doesn't fit? Where do you scroll to? Do you show the scheme or not when you scroll? IDNs, which I'll get into a little bit in a minute, makes it even harder. So Chrome has had dozens of URL display bugs over the years in various security-related surfaces, including the URL bar itself. And some of these bugs have made it very difficult or even impossible for even a highly skilled user to know whether looking at the correct URL or not. So the first thing we've been doing is both sort of burning down our bug backlog for URL display bugs, but also building tools to make it easier for people to build correct URL displays. So I think next week we'll be launching a tool, if any of you are interested in using it, that makes it a lot easier to sort of have a set of test, like attack URLs, but also really just corner cases, right? They don't necessarily need to be attacks. They can just be corner cases that make it hard to understand URL display, to make it easier to sort of run through the testing process as you launch a new UI. Another case to consider is an internationalized domain name. Those are often abbreviated to IDN. So these are domain names that contain a language-specific script or alphabet. An example might be a mix of Chinese characters with English characters, or you might have some Hebrew in part of it, which is particularly complex because then you have right to left versus left to right issues in the same URL. And I think the intention is what you want to show is you want to show the URL like in the good case with a mix of characters where someone who reads that language is going to get additional information from reading it. The problem is that some Unicode characters look exactly like Latin characters, like exactly like. You cannot tell the difference. There are characters that look just like an E but are not an E. So it's not really ebay.com, but even an expert user is going to think that it's ebay.com. Some browsers try to detect homograph attacks. That's what this class of attack is called. And instead displaying a mystifying ASCII encoding called puny code. The problem is the puny code doesn't actually, I mean, maybe it makes it a little harder, but it now just kind of turns the URL into gobbledygook. It doesn't necessarily alert you to the fact that there's an attack. And the second problem is, if you misfire, you're now also making URLs harder to read for people who are legitimately using that script in their language. So it comes at a cost there too. So what we're working on as a first step is trying to figure out ways to better identify and flag likely homograph attacks that aren't just falling back to puny code, but are explicitly warning and telling people, hey, we think that this URL is trying to mess with you. All right, so this work is still in progress. We haven't solved it, so this isn't necessarily a case study of success. But I want to try to convey two things. The first is that this is an important problem that's worth taking on, even though it's going to have trade-offs. We can't be stuck in 1994 forever with how we communicate web identity. I think that there are a lot of things we can do as a community to help explain web identity better to end users, but they are going to come with some hard trade-offs. Possibly even in trade-offs for some of us personally, if we, for example, find it annoying to not see a full URL all the time on every page. I'm also asking for your help in identifying solvable chunks of this problem. I don't know if any of you work on products that deal with displaying URLs or not, but if you do, if you have thoughts on what we can do as a community to help users understand identity better, I would love to hear suggestions. In closing, I think of security as the art of managing risk and trade-offs. You're often in a position where you want to build a new system or you want to make something better, but making it better doesn't necessarily mean that you're going to make everything better. It often means you're going to have to balance the security risks with other types of usability costs or other types of product costs. But these problems are still worth working on, and I think they're tractable a bite at a time, even though that doesn't let us avoid these really hard trade-off situations. Thank you all for listening, and with that, I'm happy to take questions. Does anyone have a mic by any chance, or?
Thank you very much. I really enjoyed hearing, especially about the process of migrating to HTTPS and trying to make it normalized. I'm wondering if it's a similar problem as older ciphers become considered less secure with time, and what lessons you might have learned from the initial transition that you would apply to a future transition of the same type.
That's a really good question. I think this is a very hard problem, and I don't think we have a good solution to it yet. But for those who aren't familiar, just having HTTPS on your website isn't enough, right? You need to keep up to date with modern standards. And as a consequence of that, we asked developers to make changes to the deployment of TLS. And eventually, at some point, when most of the web has moved, we then start showing warnings or breaking the sites that aren't meeting basic modern minimum TLS standards. And this is a bit of a chicken and an egg problem, because if you break the sites too soon, users experience very real pain when a whole bunch of websites that they want to go to break. On the other hand, if we don't break things, developers don't voluntarily necessarily adopt modern security standards. This is a hard problem. We don't have all I can do is acknowledge that it's a hard problem and say that we don't have a solution. It is something that we've tried to learn for in other areas. So for example, when we're talking about ways we can help the web move faster, for example, or shift the web ecosystem to more mobile-friendly content, we're trying to tell people, hey, looking out 5 years, here's where you should be, instead of saying, oh, here's what's good enough today, and then 5 years from now, having to tell everyone, oops, you're not meeting minimum standards. So I think that the thing to do is try to, from the beginning, like set up goalposts that have a long enough lifespan, and unfortunately, we can't go back in time and do that for HTTPS. So instead, we're sort of stuck here with this chicken and egg problem happening every year, and it actually has made HTTPS adoption harder because developers are getting these mixed messages of you need to move to HTTPS, but then also, and then after you do that, we might break your website if you don't keep up to date. So it's hard.
Thank you very much. I really appreciate your overview of the high-level process. Question. Google Labs recently deployed one of the few realistic phishing tests that one can do. Wondering, and that relates to what you said about the URL problem, and wondering if you learned anything from the results.
That's a great question. I know that Jigsaw launched this phishing quiz. Unfortunately, I haven't had a chance to look at any of their findings yet. I think they just released it very recently.
Hi. Google was one of the first browser vendors to implement support for HTTP public key pinning as a way to help users have high confidence in the authenticity of websites, but recently decided that they were going to drop it from Chrome because of its low usage rate, and there was a high cost to using it. So, but the value of it was still there. So is this a feature that Google has thought about pivoting on and doing something different to help users get that high confidence in the authenticity of the websites they visit?
That's a good question. Key pinning has been very valuable, but also has turned into a foot gun, where it's easy to accidentally brick your site, and we have seen websites do that. So even with people who are generally the websites that use key pinning are very excited about security and are sort of promising to follow best practices with key management, and then still mess up and accidentally end up breaking their site. I think initially we thought the trade-off was very clearly in favor of offering this additional tool, but over time, as other things like certificate transparency have become real, we think that the balance is sort of shifting. And one of the benefits of a more auditable trail of certificate issuances is that now there are other ways to detect these types of attacks or types of problems as they're occurring, these misissuances.
Thank you so much. Everyone, another round of applause for Adrienne.